This is a demonstration of Wirecast. 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 This is a demonstration of Wirecast.
Okay, so our 3 TMs, I will try to ask them to spread out their TA office hours in addition to the 2 office hours I'm holding, so that we can cover all 5 days, Monday to Friday. So every day you have somebody to talk to if you would like to. Does that make sense? Okay? And other than holding office hours, another duty of the TMs for this class is to do this, which is to produce a live YouTube stream feed of the lecture. So in case, for some reason, you are unable to attend the lecture physically, you are able to watch a YouTube live of each lecture. And in addition to the live feed, we will also going to upload the video of each lecture after the lecture to a YouTube channel. I will post the links to both, meaning the live feed as well as the YouTube channel for the lecture videos afterwards on campus. I will post both links over there after today's lecture so that you can leverage those resources if you would like to. That being said, I still strongly encourage, even though I do not require you to come to physically attend every lecture, but I still strongly encourage you to come to every lecture physically rather than 100% relying on these YouTube channels. Okay? All right. And one thing I do want to mention for the YouTube channel is we will ask the TMs to adjust the angle of the camera as much as possible, meaning for the most part, it will be focusing on, the camcorder will be focusing on the screen right here. But occasionally, I will need to use whiteboard right? To work out an exercise or giving out some detailed examples or do some in-depth analysis, I will ask the TMs to pay attention to those and try to adjust the angle of the camcorder if necessary. But sometimes TM may lose track of this, may not do as good a job as in keeping track of this in real time. So please bear that in mind. Of course, I will remind them as far as I can. Okay. Okay. Of course, their emails are here already, but their office hours, as I mentioned, are still to be finalized within this week. Course description, I will skip this part because I went over this already. Objective, you you actually can synthesize the course objective based on what I have said so far, right? So in short, the objective of this course is to make sure you guys have an inside-out deep understanding of a database kernel and understand both structured and unstructured data management systems in general. Okay? So, and feel comfortable of building a system as such yourself from scratch. Okay? Not just using the system, but building such a system yourself. Okay? Prerequisite, we don't really have a prerequisite per se, right? Meaning we don't have one that we will enforce, 100%. But that being said, it would be nice if you have an undergrad database class taken somewhere. Either you have taken my 5530 undergrad database class here, or you have taken a similar course somewhere else. You may wonder, what if I don't? In that case, you have to make a decision for yourself, but I think it will be totally fine, even if you don't have an undergrad database class taken before. The reason for that is I will be using the first 1 or 2 weeks of lecture time to go over the part of the undergraduate class, the part of the content from the undergraduate class that I think will be necessary for you to understand and follow along for this course. So you shouldn't worry too much about it. But that means that I do expect you to have a general CS background coming to this lecture, meaning you understand data structure, you understand algorithms, you understand the analysis of some basic complexity theorem of how to analyze the complexity of an algorithm, how to tackle a particular problem from algorithm and data structure point of view. I do expect you to have that general knowledge, which I don't think is a problem if you have a CS background. Okay? And speaking of the programming capability, okay, your programming skills. So remember, earlier I said you will be you will involve in this semester-long project of building a database kernel, right? So how does it work? Of course, I'm not going to ask you to write everything from scratch. A database system takes years to build, actually. Okay, a database system at a mature commercial level database system takes years of effort. So I don't expect you to do that. What I will do is I will hand out the skeleton, a code skeleton from a system called SimpleDB. As the name suggests, it's a simple database. But the funny thing is later on you will find it's not as simple as the name has suggested. Okay. But anyway, let's call it SimpleDB. Okay. And you will be working in a team of 2. Okay. I was debating between whether I should ask you to work on this by yourself or you should work in a team of 2. At the end of the day, I figured in order to build a mature database system, you will be, if that's what your career leads you to, you will be ending up working in a team. Nobody can build a database system single-handed by him or herself. So you will be working in a team environment anyway, so maybe it's a good experience for you to learn how to work with a teammate. Of course, why I was debating about it, because there are downsides associated with working in a team. As you know, this partnership may not work out well, right? So one person ends up doing all the work, and the other person promised to do a lot of things, but at the end of the day, doesn't deliver his or her promise. What happened in that case? I will talk about this later on. But for now, just remember, it will be a team project. And that being said, after today's lecture, I encourage you to start, if you decide to stay for the course, I encourage you to start finding a teammate. It will be best if you find a friend you worked before and you trust each other, all that. You may wonder, what if I don't know anyone in this class? I'm by myself, what do I do? Well, we will give you 1 week of time to find a teammate. At that point, I will set up a Google Doc where you will share with the class, and you go in and you enter your team information. And if you could not find a teammate by yourself, you simply enter your name, your UID, your email in that Google Doc. And then I will look at who are leftovers without partners. Then I will just do a random assignment at that point, meaning matching you with some other person randomly selected from that list. Any questions in this process? The programming language for the project, meaning the code skeleton I'm handing out, where you will be filling part of your code, is entirely based in Java. The project used to be done in C++, which I think is still probably the best way of going about doing it, because C++ is, in terms of as a language, is way more efficient than Java. If you understand how compiler and programming language works, the reason for that is very simple, because C++, the compiler will compile a C++ code or C code into native machine code, meaning they are compiled into assembly code that operate directly on your register, data register and instruction registers. Where Java is compiled, being a platform-independent language, they cannot be compiled into machine code, because if you do that, that means it will be dependent on the particular architecture you're using. So Java, in contrast, will be compiled into something called bytecode. Then the DBM, Java Virtual Machine, in runtime is kind of like an interpreter, like a translator. We look at the JVM and the underlying architecture. Why the underlying architecture matters? Because for different architecture, the instruction set is different. Okay? So JVM will, in runtime, translate those bytecode into machine code in runtime, which means the efficiency of it is not going to be as good as a native machine code. Does that make sense? So for most commercial level systems, if your goal is to strive for efficiency and scalability, oftentimes people write those system code in C or C++ for that reason. Okay? But for application level code, platform independent is a big plus, because you do not have to worry about where your code needs to be ported over to. Does that make sense? So Java, for that reason, Java dominates at the application level. Okay. So it used to be we do everything in C++ in this class for the kernel code, but then the downside of that is I figured over the years of teaching this course, I learned that many students actually do not have a strong C or C++ background coming into this lecture, coming into this class. So asking you to write everything in C or C++, especially at kernel level, is going to be a huge challenge. So for that reason, I decided to switch to Java starting from last year. So you guys are the second batch we've been doing this. So it used to be the name of the system is called Minibase, a mini database, right? Now we changed to Java. We renamed the name of the system as well. We renamed it to SimpleDB. So everything is done in Java. Okay. Well, you may ask, what if I do not have any experience in Java? Okay. Most of you should have some experience in Java, right? If you don't, here's the deal. In my opinion, if you have some experience with object-oriented programming language, whatever that language may be, C++ being one of it, and as long as you have experience in object-oriented programming, in my opinion, it's fairly easy for you to pick up Java. One of the reasons for Java to be so popular is because Java has a really, really nice support of a rich set of APIs and very well maintained documentations. So it's very well packaged, and you can write really complex functions without writing much code. if you are using Java. Most of the functions, as you can think of, chances are they are already part of the Java standard package distributed to you. You only need to figure out which class to initiate and which method within that class you want to call. So it's fairly straightforward in my opinion. Even if you don't have any Java experience, I don't think that's a deal breaker per se, right? So of course, I don't want to make that decision for you, because later on you may blame me if I don't have any Java experience and you convince me to stay, and now the boat is thinking, what do I do? So I'm not responsible for that. So before you boarding the boat, I make sure you understand what you are getting into. But in my opinion, I don't think it's a big deal. And if you view this from a positive angle, this is a good experience for you to, and good opportunity, frankly, for you to pick up Java. As a CS Master student, I think it's not surprising to see your potential employer will expect you to know Java. Okay, so this is actually a good opportunity to do that. Okay, any questions so far? Okay, no, okay. Textbooks. So we have one required textbook, which is this one. It's fairly expensive to buy this online. Okay, to buy this from Amazon. I don't know how much it costs nowadays, but it's probably over $140. So unless you have a deep pocket, then pretty much can do whatever you want, right? If you are not, if you don't have a deep pocket, I don't think it's necessarily for you to buy this book, because there are many used ones you can buy. You can also borrow from your friends from last year's batch or the year before. Or this is why sometimes I hate this live video feed. There are PDF versions of this. You can Google online if you know how to Google it. There are also international ones, international editions. Those same content, but they are restricted to be sold outside US. For example, in India and China, China is where I came from, it's much cheaper due to a licensing agreement. Okay, those are a few tricks you can try so that you don't have to pay $140 for this. But I know that also really well, Johannes and both Johannes and the others are my good friends. So if you do buy, then I'm happy for that as well, because you are contributing to them. But both of them are super rich anyway, so they care. They both are almost as, I think one of them is a Microsoft Fellow, the other one is a Microsoft one level. I think both of them are Microsoft Fellow now. So they're money-wise, they're doing really well, I can tell you that. Okay. But of course, money, right? So I don't think they will object if you decide to buy and contribute to their project, right? And so this is a main textbook. And furthermore, I want to add, even if you don't buy a textbook, I think it's okay. I think if you rely 100% on my slides, you should be fine. You should be fine. Occasionally, you might need to have a quick reference to some part of the textbook, which you can do that by checking out a copy from the library, or have a quick peek, borrow from your friends for a day or two. That should be sufficient as well. Okay. So my recommendation is don't rush to buy right away. Stick on the ride for maybe 1 or 2 weeks and see how it goes. If you really feel it's absolutely necessary for you to buy, then you can buy it. Okay. And so that's that. And there's the recommended reading in addition to the textbook I just talked about. The textbook is very distinctively identified by the cover, which is what we call the cow book, because there are a couple of cows on the cover of the book. So it's very easy to identify this. So it's by 2 professors, used to be in Wisconsin. They moved to Cornell, then now at Microsoft. The second textbook, quote-unquote textbook, is not really our official textbook, but I think it will be a useful complementary reading in addition to the official textbook. This is called The Database System, the complete book by 2, I believe, maybe 3 professors from Stanford. You can actually get a copy of this from library as well. This can be a useful complementary reading. Sometimes, because different authors have different writing styles, even for when they are talking about the same thing. Sometimes having a second angle looking at the same thing might be useful. Okay, that's why you might find this useful. Okay. Now, collaboration, academic honesty. I don't think I need to go into details of this. You guys are grad students, so basically no cheating, right? I mean, collaboration is fine, but don't copy code from each other or copy code from online. We do use mouse to check code similarity. So it's very easy for us to catch if there is a cheating case going on, right? So don't try to do that. So now, important dates. So before I talk about the dates, I will talk about the grading policy first. So currently, I'm still deciding about the weight of each module. I may adjust this slightly. Let me explain in the last minute or two. For now, your project, the kernel you will be building, over 5 or 6 projects. Okay, we start with a simple module, then we kind of like a puzzle game, right? You put one piece of the puzzle, then slowly you incrementally solve the puzzle, right? So this puzzle game will be carried out in 5 or 6 projects, depending on the progress we make. And I'm thinking about currently assign 40% of the weight to that. I'm tempting to increase the weight of that to 50%. I will let you know within this week whether that will happen or not. For now, it's 40%. Then the other 60% or 50%, if this goes up to 50%, will be split between midterm and final tests. Okay? There will be one midterm and one final test. I do not give any weight to homework assignments because from my past experience, I found out that at the grad level, almost all of you score perfectly on homework assignments. Probably you guys discuss or whatever, and plus, having homework due can be a challenge for some grad student when you have a busy schedule doing research and all that. For example, you are working on a paper that has a deadline, submission deadline that conflict with a homework assignment. So in my view, I view homework as a way of doing exercise and making sure you are familiar or comfortable with the content we cover in lecture. It's not necessary to be graded and counted towards the grade of your performance in this class. So for that reason, I will still hand out written assignments, but written assignments are not required to be turned back in. Your solution to those written assignments are not required to be turned back in. Rather, what I will do is I will hand out a written assignment. Then 1 or 2 weeks after a written assignment has been assigned, I will release solution in our course website. I strongly encourage you to solve those problems, if not all of them, but at least most of them, before quote-unquote the due date, which is the day I release my solution, so that you can check against yourself. But homework is not graded, and it will not count towards part of the grade of this course. Okay, any questions regarding this model? Of course, there is a potential downside of this, which is all human beings, as far as I know, have a tendency of being lazy. Right? That's just the nature of the beast. Meaning that if I don't have a due date, and if this is not graded, most likely you will end up not doing it. Okay, you will end up not doing it. Well, at the end of the day, I figure is the lesser of two evils, right? Whether I force you to do it or have a physical deadline, you turn in your homework, but then make your schedule really packed and not flexible, versus giving you the trust and giving you that flexibility, and you can control your own pace. Because the fact that you don't have to turn in your homework at the due date, you can actually adjust your pace, right? For example, you are super busy this week, fine, you can work on the homework even after due date, just making sure you don't look at the solution I post. Okay? So that's the way I'm going to do this at grad level. Okay? So in addition to homeworks, I will also release quiz from time to time. And again, the quiz will not be part of your grade. but I will design those quiz problems similar to those problems you will see from the final and midterm tests. And I will also give a time requirement on each posted quiz so you know how long you should be spending in solving a particular quiz problem. And quiz come with solution at the end. So you time yourself, for example, a quiz of 15 minutes of 2 problems. You try to solve those 2 in 15 minutes, and at the end of that, you check the solution at the back. And that gives you an idea how well you are doing. Okay? And both the final and midterm tests are going to be open book, meaning you can bring your textbook, your lecture slides, homework and homework solutions to the test. And the only thing is you cannot pose a question on Stack Overflow, for example. Okay, that's not allowed. And you cannot send a messenger message to your friend. Okay, things of that nature is not allowed. But other than that, it's an open book test. And the problems you will see from the final and midterm test, I promise you will be 100% similar to the problem you have done in your you have seen from your written assignments. Not the same, but same type of problems. So as long as you do your written assignments, you should have no trouble in doing well in the final and midterm tests. Okay. Any questions so far? Yes.
When is the deadline of the project?
When is the deadline of the project? That's a good question, but before I answer that, let me talk about the dates for the final and midterm, because I know some of you would like to make your travel arrangement way ahead of time. For example, some international students are trying to go back to their home country in December when flights are really expensive. So you want to know your travel schedule ahead of time. So I post the date already. So the midterm will be October 17, Tuesday, which is the first Tuesday right after fall break. So it's very easy to remember this. The first Tuesday, when you come back from your fall break, that will be the midterm test. Okay? The final, we're going to do this before the final week. The reason I'm going to do this is I want to utilize that week of time for you to maybe do one more project rather than preparing for a final test. And another reason I'm doing this is because we split the course content by midterm and final, which means the final test will cover only the second part of the course. The final will not be a comprehensive coverage of the entire content. So, meaning the scope of the final test is relatively small compared to a real final that covers everything. So there's no need for us to do that with the university final test time for 2 hours. I think we can do it within the normal lecture time anyway, just like the midterm test. Okay? That's why we're going to do final on Tuesday, December 5th, the Tuesday of the last week of lecture. And after the final test, since we're doing this early, I do expect you, depending on the progress we make, I do expect you to maybe still working on the last project in the final week, okay? Because of this arrangement. Okay? Any question on this? On the final and midterm tests? Okay, open book. Midterm cover everything start from today until the end of, right before fall break. And then you have your fall break to prepare for the midterm test. Coming back, you do the test. Okay? Then final cover only the second part of the course, meaning you don't have to worry about anything that's already tested in the midterm. And it's open book. Both are open book tests. Now, speaking of the product, okay, we will be releasing the first product maybe next week or the week after next week. And from that point onwards, it will be back-to-back, meaning first product released, 1 week or maybe 2 weeks later it's due. Whenever a product is due, the next product will be released. And you will be, this is important, you will be building your product incrementally over the modules you are building. Okay? And you may wonder, what if one particular product, my team, doesn't solve all the puzzles in that product? That they prevent me from going forward, right? That's possible, right? That's possible. If one product is really challenging, you solve most, but not all of it. And because each project module are dependent on each other, does this mean you cannot proceed from that point onwards? Well, if that happens, talk to the TMs. We will ask the TM to distribute quote-unquote solution code to the part you are not able to figure out, so that you can still continue on. Okay, that make sense? Okay. Now, one more comment on the project. The way we're gonna handle the project is you do this in a team, and each team gonna set up a private Bitbucket repository. So everything is gonna dump in Git. And at the due date of your project, you don't have to submit any code. You simply make sure you commit your local changes to the Git repository. And I will ask each team to add the TM's Bitbucket account to access your private Git repository. So after due date, they simply check out your code and do grading from there. So it's very easy. And in this process, you will learn how to use Git, how to do branching as well. So it will be a useful learning experience for you as well. And we go with Bitbucket because I think Bitbucket has free accounts for all students, as well as you register a Bitbucket account using a .edu email address. And if you do that, you will also have access to unlimited number of private repositories and unlimited number of collaborators. As far as I know, that's the case. Right? If that's no longer the case, we can switch to GitHub. I think GitHub has a similar deal as well. But Bitbucket and GitHub are the same, right? They are both a Git code management system. So we'll be using Git for that purpose. And you will be, and basically you will be building different modules using Git and committing your code to this. Just make sure you do commit your code before the due date. And the TMs will look at your commit history to make sure that they're looking at the version of your code for a particular product before the due date of that product. Okay. Any questions regarding this part? Okay. So the grade distribution. So it's a fairly generous grading scheme, and everything is very transparent. Based on that formula on top, which might subject to some minor adjustment, I'm strongly leaning towards increase the product portion by 10% more, because product is a very heavy portion of this course, right? So maybe 50%, 25, 10, 25. That's how you look at it. At the end of the day, it will be a weighted sum, and each product carries the same weight. Meaning, suppose that's 50%, and you have 5 products, then each product bears 10% of the weight of your final grade. Okay? So it's a weighted sum at the end of the day, and each product or final or midterm test, the full point is 100 points. 100 points. So it's a simple weighted sum of the scores you get in each module, and then you check against this table. If you are between 92 and 100, you get A. If you are between 83 and 91, you get A minus. What about if you got 91.4? Well, we do rounding. 91.4 will be rounded to, unfortunately, 91. 91.5 above will be rounded to 92. But if it does apply to you, for example, you are unfortunately in that category of 91.4, you can actually come to my office and review your midterm final, try to find 1 point somewhere. Near 1 point will bring you from A minus to A. I do understand that. And when I was a student, I was in a boundary case once, and I made a strong argument, and I failed at the time in that case. But I do understand where you come from. Right? If you are in a really boundary case, you can come to my office and try to find 1 point somewhere to boost you up to the next level. But if you are 90 point something, then chances are you won't. That won't happen. Right? Okay? You will be end up in A minus. So on and so forth. So grad students, I believe grad students need to get at least a B grade in order for you to receive credit. Right? Is that right? Maybe different track have different requirements. I think it's at least B or B minus.
I think it's like if it's required by your track, then it's like a B minus, but if it's just some random class you're taking, it can be a C.
Can be a C? You
I
sure about that?
don't know.
Okay, double check the grad handbook. But let's assume you are targeting for at least a B grade or better. Look at this, you only need to score above 53 points. That's like, you have to pull out some really nice stunt in order to be lower than B minus. And B minus is, right? Oh, sorry, B minus is 60 points, right? So B is 67. So in order to be lower than B minus, which I believe is a requirement for most track, meaning you score 60 points or less, you really need to do some stuff, right? Because it's open book, everything. The midterm final tests are similar to the written assignments, and you heard that you're working with a team. Unless either you or your teammate completely give up the project, you should be able to score at least 60 points, in my opinion. The project is already 50%. In my experience, most teams end up doing really well on project. They score 80-ish or 100 on all projects, at least. Then midterm final, depending on how much effort you put into the course, most students score at least 80 points in midterm final because it's open book, the problem are similar to the written assignments. Unless you are come and go, right? You just come to lecture, you don't do anything after the lecture, and then come to the final. In those cases, you might not be able to do that well. But even in those cases, scoring 60% or higher should not be your challenge. Okay? Should not be a challenge. But that being said, since I'm being so transparent with everything, right? If you are unfortunately in this category, in C or whatever, don't come to my office and say, oh, I'm a grad student, I need to score at least this. It is what it is, okay, at the end of the day. It is what it is at the end of the day. If I can find 1 point to bring you from a C plus to B minus, I will do that. But if I'm unable to find 1 point, even if it's just 1 point, 1 point is 1 point. Okay? If I go to a restaurant, if I pay $1 less, they won't let me out of the restaurant. It's simple like that. Okay? It is simple like that. Not even $1, try a quarter. Some restaurants won't let you leave the restaurant without paying that last quarter. Right? So it is what it is. But if that unfortunate case applies to you, I will try my best to review your work and find 1 point somewhere if you deserve that. Okay, that's the key word. If you deserve that, you are not entitled for that 1 point. There's a big difference between you deserve and you are entitled for that. Okay, many students in my training, and many people, frankly, in this nation, now developing this tendency, I'm entitled. No, you are not entitled for this. You are not entitled for anything. You earn what you deserve for. Right? You are not entitled to anything. Okay? All right. I think that's all I want to say. Okay? And there's a detailed plan of the course. If you are interested in reading it over, I have no intention of going over this now, and I just dive into the details if you allow me to. Any questions? Yes.
Regarding to the prerequisites, what if I don't have a background of Unix?
Background of Unix. Okay, that's a good question. So, since we're doing kernel development, right? But the good news is we're doing this in Java, right? So it's a platform-independent language. You can actually do this in Windows, right? Windows operating system, no problem. You can set up the project using an IDE. IDE stands for Integrated Development Environment, being Eclipse, being whatever that you are comfortable with. You can use the IDE on top of any operating system of your choice. So I don't think it's absolutely needed for you to have a strong Linux background. But that being said, we will be also, in addition to the product, we will also be interacting with a real database system such as PostgreSQL. And that will be, the server will be running on a Unix box. So if you want to, depending on how you access that server, you can use command line interface to do that. Then definitely you need a Unix, some Unix skills. But if you are using a client program to access that server running on the Unix box, that client program can be running on whatever operating system of your choice. Because PostgreSQL is such a popular database server, there are many different client programs people have developed in the community for different OS that you can choose to work with. But I strongly encourage you to, along the way, develop some Unix skills by taking this course. Okay? but it's not required as a prerequisite coming into the course. Okay? Any other comments before I dive into the details?
So will the scores be curved based on the performance of the whole class?
Say again?
No.
There will be no curving. As I said, it will be strictly depending on that table. If all of you get A, you deserve for that A. Fine. If all of you got B, then no A, then no A is no A, right? So there will be no curving. So you don't have to worry about your relative performance to the class. You only need to care about what's the total weighted sum of your score with regard to that table. So you don't have to worry about relatively where you are. Okay? So it's very, very transparent and very independent of how others are doing in the class. Okay, any other comments or questions before I start today's lecture? So before I start today's lecture, I want to mention one thing. Is I want to make this classroom as interactive as possible. What that means is you can interrupt me anytime. Just raise your hand, or if I'm writing something on the board and not seeing you, you can just shout out. Say, I have a question. What about this? Okay. Sometimes, occasionally, if I'm really tight on schedule in that one day's lecture, I'm trying to finish what I'm trying to cover because of the homework I want to release or a project to be released, depending on that particular component I'm talking about. I may ask you to bring a question, really a lengthy discussion offline. When that happens, I ask for your understanding, but in most cases, I don't expect that will be the case. But in either case, you should ask, no matter what. If I feel like it will be a lengthy discussion and it affects my schedule a little bit, I want to take that offline, I will politely tell you that, and we will do that offline. But other than that, feel free to ask questions or interrupt me anytime. Okay? And if you come back to the course homepage on Canvas, I set up different folders under files. There's a folder called lectures. Oh, log in again. Oh, by the way, I think one of you registered for session 2. Everyone should register in session 1. Even if you're big data certificate students, you should be in session 1. Everyone should be in session 1. If that applies to you, try to add session 1 and drop session 2. If you need a permission code to do that, send me an email. I will give you a permission code for session 2. Session 1. Everyone should be in session 1. No matter which program you are in. Okay? You should be in session 1. Now, if you go to files, and there are different folders as I mentioned, project, quiz, written assignment, this will be released later on. So now you will find a copy of syllabus and all the lecture slides over there. Okay? For lecture slides, I release 2 formats, the PPT format and PDF format, depending on what you prefer to use. I ask you not to distribute the slides in public domain, so it's only for your own reference when you are taking this course. As well as, one more thing is, all the projects, all the written assignment solutions, midterm final solutions, please do not take it to public domain. Meaning, your GitHub or Bitbucket repository, even after you finish taking this class, please keep those repositories private and do not make them public. The reason for that is so that other students in some other institutions or future students from this class will not be able to Google and look at your code. Okay? One more thing before I proceed. I also posted something called, where is it? I think maybe I forgot to post it. So I will upload here. I thought I did. Maybe it's under written assignments. Yes, there's a file called altsolution.pdf. What is that? So that's the solution to all the odd number of questions for all exercise after each chapter in this textbook. Okay, for each chapter in this textbook, they provide a set of exercises. right? And for all number of questions, the solution to those questions are provided in this document for your reference. However, that means that you may wonder, what if I don't have a copy of this book? I don't even have access to those problems. Don't worry about it. All the homework solutions, all the homework assignments, written assignments, will not be from the textbook. Okay, they are designed by myself, and I will release them in PDF. And the solution will be posted as PDF files here as well. The all solutions file is really for you to do more exercise if you feel that's needed. I don't think that will be the case, but in case you want to do more exercise on your own and check the solution for what you have done, this is the way to go. Okay? Yes?
So I was wondering, so if our team is like really familiar with GitHub and already has like access to private accounts, can we use GitHub?
Yeah, I don't think that will be.
Okay.
I don't think that will be a problem. Let me think about it. I mean, I think you just add TM's GitHub account rather than Bitbucket account, but would that be a logistic nightmare for TMs? I have to think about that. On top of my head, I don't think that will be a problem. Okay, so let's start with today's lecture. So we don't have much time left, but I will go as far as I can. As I promised you, I will do a quick overview of some of the basic concepts involved in a relational database system. Some of you may find this part not so interesting because you have learned this from an undergrad database system class. If, for example, for those who have taken my 5x30 class, but nevertheless, I think this will be a useful and good recap of those knowledge and concept, and prepare yourself ready for the kernel part of the discussion. Okay, and that means that I will try to go over this part somewhat in a quicker pace for that reason. Okay. So relational model. So if you look at the data system landscape, it's really a Wild West. At the moment, right? Wild West meaning that there are many different products or systems you can choose from. For example, you might not have used all of these systems, but you probably have heard some of it, if not all of these names, right? Somewhere, right? For example, Hadoop, Spark, Hive, HBase, Redis, MongoDB, Oracle, MySQL, PostgreSQL, MySQL, SQL Server, Neo4j. Why we need so many systems for the same task of data management, managing the data I got, right? So database, if you look at this word, it has basically two words in it, data and base, just like an airbase, right? Airbase is for storing and managing your airplanes, right? So database is a place where you manage your data. Okay, that's where the word comes from. If you generalize this term of database, you are in this space called data management. So the data management space is about storing, processing, and managing your data, whatever that data might be. It could be text data, could be table data, could be image data, could be video data, right? Whatever data you want to store at a place and do some management and retrieval later on based on some conditions, we refer to all of this as a data management system. Okay. So for this simple task, sounds like a simple task of managing, storing your data. Why we need so many different systems? Okay, that's one of the questions we set out to answer through the study of this course. Okay, why we need so many systems and how they are similar and dissimilar to each other. Okay, and if you think about one simple way, kind of like a global solution to the data management problem I just mentioned. You can use one of the systems I mentioned in the first slide, or you can choose a hardcore route. If you are a computer science student, you can choose a really hardcore route. The hardcore route is this, right? You have your file system, right? And no matter, doesn't matter what kind of file system it is, right? Whether it's NTFS or in Unix you have different kind of file system, whatever file system that is, it gives you a way of manage to manage a set of files, and each file stores some data of your interest. Okay, so one way of doing this, solving any data management problem, is to go through this route, which is I have my file system to store my data. I split my data into one or multiple files, storing my file system. Then through my operating system, either Windows or Unix or Mac, I interact with my file system. And through my operating system, I choose a programming language, a high-level language, Java, C++, Python, whatever, to open and save, to read and write data from those files. Then I develop an application program using the language of choice. And the user interact with the underlying data using that program. So this is a universal solution, right? If today I ask you, okay, University of Utah wants to manage student data. You can do this, right? You can say, okay, I'm going to store this student data in this many files, and I'm going to write a program and tell me what you want. I will develop each method, every little method you want me to do, and you interact with the student data through the method I have developed using whatever programming language I have chosen in the first place. So this is one route. The other route is you use a data management system, for example, a database, to manage your data, meaning that you do not interact with the underlying file system directly. You no longer see files anymore. You don't see any files. You have some higher level abstraction meaning this is on top of your file system. So you no longer see individual files, you see some higher level abstraction, for example, tables in a database system. And then your database is running on top of your operating system, but you don't write a program from scratch to interact with data from this layer. Rather, you use some system that's being packaged well for you, for example, a database management system, and there is a customized language in that system, for example, SQL, structured query language, you use to interact with the underlying data. So this is another route. And this is pretty much the route taken by any of the systems I mentioned in the first slide, right? So you may wonder why people end up doing this most of the times rather than this. The reason is as computer systems become increasingly more and more complex, and as data, the volume of data grows so big, the first route simply becomes unscalable. Okay? And there are too much reinventing the wheels going on if you go through this route. Person A has done that, and person B has to do something very similar, and why you do that? Why not, if that happens all the time, why not do a higher level abstraction and provide a unified interface for users to interact with? Okay, that's essentially the motivation behind the design and adoption of many of the data management systems, okay, on the right-hand side. And so we will be focusing on this part. If you are in a programming class, for example, you are learning how to write program in Java or C++, most likely you will be here. You end up here, right? You design some small files to manage to store your data. You write a program, interact with data using some data structure or algorithm. You do this, right? But at a small scale, that scales well. But if you are talking about large amount of data, multiple users, concurrent access, and all that, you have to do some level of abstraction. Which is on the right-hand side. Okay. So if you break up this box, so what's going on here? What's in that abstraction? What's inside that abstraction? So let's break up that box. So inside that box, inside that abstraction, what's really going on? So this is a really typical architecture diagram for any data management system. Right? It doesn't really just apply to relational database system, but it applies to literally all kinds of data management systems. Typically, you have an application interface, such as your web interface, your hotel check-in application interface. Then you have a SQL interpreter, meaning whatever interaction user are doing through that through that application interface will be translated into some customized language, for example, SQL, structured query language. And this translation is done automatically by that application interface, right? So for example, user specifies some condition, and your program will construct an SQL query based on those conditions. And so that SQL statement now will be passed into an interpreter, a translator, to translate a SQL representation into something the underlying database kernel can actually understand. And once that's completed, you will go through this process of what we call query evaluator, meaning you generate a query plan. I'll give you an example of that, right? I want to go from Salt Lake City to Boston. So that's what you will do at the application interface. And this will be translated into a SQL statement such as select route from Salt Lake City to Boston. Select possible route, meaning it's doable, right? From Salt Lake City to Boston. But if you think about it, there are many, many different routes going from Salt Lake City to Boston, right? I can go, for example, one possible plan is having a helicopter go to the hospital. I ride up to the hospital, I ride the helicopter to Salt Lake City International Airport, take a jet, boom, I'm in Boston. That's one route. If your pocket is deep, right? And if you are not in that category, which most of us are, what do? You will take a Uber or bike to Salt Lake City International Airport, take a flight, and you're in Boston. Or there's another possible plan, which is you rent a car or you drive your own car, and if that's your choice, then in that subcategory there are many, many routes. Right? Do you go through Chicago or do you go through Nebraska? Personally, I will go through Chicago if that matters. But for some reason you want to go through Nebraska, fine, you go through Nebraska. Okay? There are many, many different routes. Does that make sense? So this simple example illustrates what? Illustrates there are many possible plans of doing the same query. Obviously, some is more efficient than others. Some is more efficient than others. For example, the very first option I mentioned is the most efficient one. Take a helicopter to Salt Lake City Airport, take a private jet, go to Boston. But the most efficient one not necessarily is your best choice because it comes with a level of resource consumption that you may or may not want to pay. Does that make sense? So it's always a trade-off between the efficiency or scalability of your plan and the amount of resources you are willing to pay. So this naturally forms an optimization problem, which is given a budget on the resource you are willing to pay or you can actually afford, what is the best possible plan to get one thing done, to get something done. And that's why you go through this loop. You generate a new plan, and you optimize this plan. And you keep doing this iteration until you find a plan that you feel good enough and are within the resource budget that you're willing to pay or you can afford. Then you execute. At the end of it, for example, back to that earlier example I mentioned, going from here to Boston, I give you a few choices. Helicopter, private jet, or Uber to Salt Lake City, take a flight, or drive from here to Boston. And in the driving category, I give you also two routes, Nebraska, Chicago. Now you have these few choices, what's your plan? No matter what plan you choose to go with, you have to actually then execute according to that plan to get what you want. So there is an execution as well. Does that make sense? There's that. And when you talk about execution, this is a physical action you are doing, right? A physical action. So when you talk about the plans, there are some tricks here as well because given a fixed plan, there are different ways of executing that as well. There are different ways of executing that as well. For example, taking the driving option as an example, and let's say you do decide to go with Chicago, you drive from here to Boston, there's still a difference in what kind of car you're going to use, where you stop. These are what we call execution details that matters too. You may have a perfectly good plan, but if your execution is bad, it may turn out to be a bad plan as well. Right? So execution matters as well. Using that as you can imagine. Right? So we will talk about all of this. Now, in order to do all of this, for example, in order to figure out the plan from Salt Lake City to Boston, you cannot do this without any help with some help of external information. For example, if you are talking about taking a flight from Salt Lake City to Boston, you need to know what are the available flights and what are the costs of each flight. Does that make sense? What's the departure and arrival time? What's the price of each flight? This information do not come for free. Do not come for free. Right? Somebody has to do something. Right? You may wonder, wait a minute, this is free. I go Expedia.com, everything's there. It's free, right? Well, the reason everything is free there is because Expedia has done all the heavy lifting for you, and why they're doing it? There are no free lunch. By doing that, they attract a lot of customers to their website. Then they make a revenue, they make a profit by doing advertisement or charging a small booking fee. And somebody has to pay something at the end of the day, right? So that means that this layer right here are different modules people have designed to facilitate those modules on top. In order to do plan generation, in order to optimize your plan, and in order to execute your plan, some other modules need to be in place to provide the information that's necessary for you to make a decision and in order for you to execute your plan. For example, you need to have a gas station along the way in order to drive from here to Boston. If I remove all the gas stations from here to Boston, no matter how nice a car you get, you won't be able to reach your destination. Does that make sense? Okay? So those modules are transaction manager, buffer manager, security manager, file and index manager. We will go over each of the modules in this class. And you will be building each of these modules along the way. Okay? You will be building each of the modules along the way. Then at the bottom, so far this abstraction up to here is not DBMS. And your database, which consists of the actual data, the physical data you have, are actually stored as part of your file system. It's just that as a user of a database, this level of details are being abstracted away from you. So there is this level of abstraction that hides the fact that these tables are actually files in the underlying file system. You don't see files, you see a bunch of tables. But if you dive into the kernel of the database system, you will realize your database is nothing else but a collection of files. And in order to manage these files, you have some metadata about the files to understand the structure of these files and to access these files. It's pretty much like you are writing a code to interpret a binary file. How many of you have done that before? A binary file. How do you do that? Well, you need to have some metadata information about the binary file. If you don't, nobody can actually interpret that binary file. You have to understand the first 2 bytes represent an integer value of something. The next 4 bytes is a floating number of something. If you don't have that information, how do I know whether I should pass the first 2 bytes or first 3 bytes into a structured value of first 1 byte? You have no way of making that decision. If you don't have that metadata information available to you, this binary file is nothing else but a collection of junk bytes to you. Does that make sense? Okay? In fact, when I was a high school student, I was first introduced to the computer through computer games. What a surprise. Okay? And as part of that process, I was playing some strategic games, meaning you control, for example, you control a kingdom, your goal is to grow your kingdom and defeat other kingdoms. In the process of doing that, oftentimes you try to cheat, right? The way to do that is you somehow get into the memory space of your game, and you modify the value of how much money you have and how many soldiers you have, and all that, right? How do you do that? Well, in order to do that, you need to to do exactly what I have just said. You know this is the memory space for the heap space for your program, for the game. Game is just a program, right? They have a heap space. And you look at that heap space, you know, oh, the first 2 bytes represent the name of my kingdom. I don't care. The next 4 bytes represent how much money I have. Once you figure that out, bingo. You change that byte value, then come back to your program, you're a millionaire. You can easily defeat whatever kingdom you want. Does that make sense? I used to do that all the time until the game developer realized you are doing this. So what they will do something called dynamic memory management, meaning that they will not use the same location in your memory space to store that value, how much money you have. Rather, they shift that all over the place. That makes sense? Initially, the first 2 bytes, the name of your kingdom, then the next 4 bytes represent how much money you have. Then, with some regular patterns or rules subject to the logic of their program, they will shift the location of the money of your kingdom to some other bad locations. So if you simply modify that, it no longer works and actually will corrupt your program. But you can, with them, develop dynamic tracking algorithm to track where they're moving this to, right? So it's always a cat and mice kind of game. Right? Until I grew up enough, I realized if you keep playing computer games, you won't make a living. Right? At that point, I stopped. But then, 20 years later, I realized, or maybe 20-ish years later, I realized if I stick on that path, I may be richer than what I am today. Right? Because now obviously there is a competition going on. By playing games, you can be millionaire by doing that. I mean, if you do really well, right? So there's that. So basically, coming back to database, that's pretty much what this module is about, right? So of course, it's different from managing data in a game, but the principle is similar to that. Okay, principle is similar to that. So that's an overview of what's going on inside database. One thing deserves a little bit more discussion is transaction manager, which you typically do not interact with outside, maybe outside a database system. Why we need so-called transaction manager, and what is the transaction? And this has to do with the use case of data management system or database system. A database system or data management system oftentimes is used by not only one user. If you think about Amazon.com, behind Amazon.com is a huge database, of course, storing their products, items, who has ordered what, and so on and so forth, right? And it's not that one user is accessing Amazon.com at any given time. At any given time, there's millions, thousands at least, if not millions, of users are browsing Amazon.com website, and even worse, they're making orders at the same time. And this creates a problem for the underlying database system. For example, you claim, okay, suppose after today's class, all of you go to Amazon.com to try to buy this book. For some reason, all of you have a rich pocket, you want to go and buy this. And Amazon.com shows that, okay, unfortunately, I have only 20 copies of this book left. And we have about 40-ish, 50 students here. All of you each try to buy a copy of this book. And let's make the situation even worse for Amazon.com. Suppose all of you coordinate with each other, like in a WeChat group or in a Messenger or Snapchat group, saying that let's all click order at the same time. Right? Okay? Let's click order at the same time. So from Amazon's point of view, if you don't design this properly, you view each user as an individual access to try to buy one book. You look at this, I have 20 copies, he or she is trying to buy one, I can serve that request. But if 50 of you try to place the order at the same time, meaning update some value in the underlying database simultaneously, if nothing is done at the database level, this will go wrong. Amazon.com end up confirming 50 orders that he actually cannot honor the request for. Does that make sense? And that's what we call transaction manager. And for that purpose, there is correct recovery and concurrency control done for that. And that's why when you go to Amazon.com, of course, one way to solve that problem is you ask Amazon.com users to coordinate with each other. Okay, you go first. When you're done, call me, I will go. If that's the business model, I'm going to come will auto business fairly soon. Right? So obviously that's not. The model is all of you go, and without any coordination, somehow magically everything works. And that's because we have something called transaction, and there's the transaction manager module inside database to manage that. And with that, I stop right here, and we will continue on Thursday.